good day to everybody. This is object-oriented programming, and in today's class, we discuss about functions, inline functions, what are the default arguments, and we try to return by reference. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we discuss about the inline functions, especially available in C++. What are the advantages and what are the disadvantages of inline functions? What about the programming style? What about the C language and macro setup? So that we'll be discussing. Then we discuss about preprocessor macro. Okay. Right. Then we discuss about some default arguments in C++. What are its advantages? What are its disadvantages? So that we'll be discussing. Okay. Then what are the default arguments? How you will return by reference in C++? And of course we will have an example. Okay. For return by reference. So I've already given the independent work for you. Please complete them as soon as possible in the MS. As I told you the deadline. Okay. So at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. So this is the inline function. Definitely it's a very much important feature available in C++. So we try to understand why the inline functions are being used and what is the actual purpose of using this one. Okay. So when the program is going to execute this function call instruction, the CPU is going to store the memory address of the instruction following this particular function call. It is going to copy the arguments of the function on the stack, and it is going to transfer control on the specified function. So this is the way like the CPU will be executing this particular function code. It will be storing the function return value in some predefined memory location or maybe register, and it is going to return the control to the calling function. So this can become like an extra time. Okay, it can become an overhead if the execution time of the function is lesser than the switching time from the caller function to the called function. So the called function, you can call it as a callee. Okay, right. So for functions that are large enough, or maybe it is performing like larger complex task enough, so the overhead of the function call is usually considered insignificant when it is compared to the amount of time the function is going to take to run. Okay. So but however, for smaller commonly used functions, the time actually needed to make the function call is a lot more than, it's much more than the time needed to actually needed to execute the function's code. Okay. So this overhead, it might occur for smaller functions because the execution time of the smaller function is lesser than the switching time. Okay, so that's the reason C++ you have inline functions in order to reduce the function call overhead. So inline function is especially a function that is expanded inline when it is being called. Okay, so when the inline function is called, the whole code of the inline function gets inserted or will be substituted at the point of inline function call. Okay. So this one you are going to have it with the C++ compiler at the compile time. So inline function can increase the efficiency if it is very small. Okay. So this is the syntax: inline return type function name. So we will have some parameters. Okay. So that's where you will have this function code. So inlining is just one request to the compiler and it is not a command. Okay. So the compiler can also ignore that request for inlining. Okay. So compiler may not perform the inlining, like if the function is going to contain the loop, okay, maybe for like for loop, while loop, do while loop, and if the function contains static variables, if the function is recursive, okay, repeating, okay, and if the function return type is other than the void, and maybe the return statement does not exist in the function body, or maybe if the function contains a switch statement or maybe go to statement, okay, so compiler will not perform the inlining operation. Fine. So there are some advantages. Function call overhead does not occur. So that extra time it will not take. Okay. So it also saves the overhead of the push or maybe pop variables on the stack when the function is being called. Okay. So it also saves the overhead of the return call from the function. Okay. And when you try to inline a function, so you may enable the compiler to perform this context specific optimization on the function body. So some such optimizations are not actually possible for normal function calls. Okay. So but other optimizations also you can perform by considering the flows of calling context and the called context. Okay. So the called context, of course, you know it's a callee. Okay. So inline function may be useful especially for embedded systems. Okay, because the inline can have like less code than the function called preamble and return. Okay. So there are some disadvantages. It's the additional variables, the added variables from the inline function is going to consume additional registers. So after the inlining function, if the variable number which we are going to use it in the register, increases, then they may create an overhead on the register variable resource utilization as well, which means that when the inline function body is substituted at the point of the function call, the total number of variables which is actually used by the function also gets inserted. Okay, so that's a problem. Okay, so the number of register going to be used especially for the variables will also get increased. So maybe if after function inlining variable numbers increase drastically too much, okay, so that might create an overhead on the register utilization. So this is the problem. Okay, and if you use too many inline functions, then the size of the binary executable file will be much larger. Okay, so because you repeat the same code again and again, you duplicate the same code again and again. Okay, and too much inlining also reduces your instruction cache hit rate. So that will be reducing the speed of instruction fetch from that of the cache memory to that of the main memory or maybe primary memory. An inline function may increase the compile time overhead. So if someone changes the code inside the inline function, then all the calling location has to be recompiled, because compiler would require to replace all the code once again in order to reflect the changes. Otherwise, it will continue with that old functionality. Okay. So inline functions might not be useful for many embedded systems. Of course, it's an advantage, but it is also a disadvantage. Okay, because in embedded system, code size is very much important than the speed. Okay, right? Because when the code size is very much large, repetitive, also you cannot perform instructions. Okay. So inline functions might cause thrashing effect, because inlining might increase the size of the binary executable file. So thrashing will degrade the performance of the computer. Okay. So we'll try to use inline function. So hash include IO stream using namespace std function. So inline int cube of int s. Okay, so you return the cube. So s multiplied by s multiplied by s. Okay, so here int main function. Okay, so C out. So this is the driver code. Okay, so the cube of 3 is. So you are going to calculate the cube of 3. Okay, and return of 0. So suppose if you substitute like s value, so 3. So 3 multiplied by 3 multiplied by 3, it is Igrama yetta. Okay, so cube of 3 is 27. Okay. So you can also define this inline function inside the class. So all functions defined inside the class are implicitly inline. Okay, which means that all the restrictions of the inline functions is also applied here. Okay, so if you need to explicitly declare inline function in the class, just declare the function inside the class and maybe define it outside the class using the inline keyword. Okay, so for example, you will have class s, public class, inline in square of int s. So this is the redundant usage of inline. Okay, so this function is automatically inline function word. Okay. So this is what you call to be a very bad programming style, because the best programming would be like you have to write the prototype of the function inside the class and you have to specify it as an inline in the function definition. So for example, class s. So you'll have public class in square of int s. So this is how you try to declare the function. Okay. Then you will have the inline prefix, inline int s square of int s. So this is using the inline prefix. Okay, then you'll have a block of codes. Okay, right. So you'll have the best programming style, hash include IO string using namespace std function, class operation. Okay, so here you'll be having int a, b, add, subtract, multiply. But division you will have float type. Okay, so public class void get, void sum, void difference, void product. Okay, then void division. Then you will go with the inline statement, inline while operation, okay, so you'll have get. So C out, enter the first value. So that is the first value. So C in, it is nothing but A. Okay, so C out, then you enter the second value. Okay, so C in, it's nothing but B. Okay, so you'll have inline while operation of sum. Okay, so you begin with this one, add is equal to A plus B. So C out, addition of two numbers, it's nothing but A plus B. Okay, then you will have inline void operation difference. Okay, so sub is equal to A minus B. So C out, difference of two numbers. So that you will be having. Okay, so A minus B. Then inline void operation product. So we already defined mul. So mul is equal to A multiplied by B. Okay, so C out, you are going to print product of two numbers is nothing but A multiplied by B. Okay, and similarly inline void operation division. So div is equal to A by B, A divided by B. Okay, so this one you remember, it's a floating data type. Okay, so C out, division of two numbers is nothing but A divided by B. Okay, then you have the driver code in main function. So C out, program using the inline function. Okay, so operation yes. Okay, so then finally yes dot get, yes dot sum, yes dot difference, yes dot product, yes dot division, and finally you terminate, return 0. Okay, so in the output you will see enter first value 45, enter second value 15. So addition of two numbers, what is that? 45 plus 15. What is it? All the mesh. Okay, then difference of two numbers 45 minus 15, put this. Product of two numbers 45 multiplied by 15, 675. Division of two numbers 45 divided by 15, ouch. So that is where you will get the output. You will have the C language and macro function. So here the preprocessor is going to replace all the macro calls directly within the macro code. So which means that you have to always use inline function instead of macro. So according to John Strostrup, who is John Strostrup? Created C++, C programming, C++. Okay, the creator of C++. And you shouldn't say Bijan, John. B is silent. John Strostrup, the creator of C++. That the macros are almost never necessary in C++, and of course they are error prone. Okay, so there are some problems with usage of macros in C++. So macro cannot access the private members of the class. Macro look like a function call, but they do not. Okay, so you will have hash include IO string using namespace STD function class yes. So you will have int m, public class you will define mac. Okay, yes m. Okay, then you close this one. Okay, so the C++ compiler is going to check the argument types of the inline function, and maybe you are going to perform these conversions correctly. Okay, so but preprocessor macro is not capable of doing this thing. Okay, what the C++ compiler can actually do. Okay, preprocessor macro cannot do it. Okay, so one thing is that the macros are actually managed by the preprocessor, and of course inline functions which are actually managed by the C++ compiler. So that is the advantage of using the C++ compiler, which is not possible in the preprocessor macro. Okay, so it's very much true that all the functions which are defined inside the class are implicitly inline, and C++ compiler will perform inline call of the functions. But actually C++ compiler cannot perform inlining if that function is virtual. Okay, so the reason is call to a virtual function is resolved at the execution time instead of the compile time. So virtual means like you have to wait until runtime, and maybe inline means during compilation, if the compiler doesn't actually know which function that has to be called and how it has to be performed, the inlining function that it doesn't know. Okay, so it's very much important to remember, to make the function inline. Okay, if the time spent during the function call is more when you compare it to the function body execution time. Okay. So this is an example where inline function has no effect at all. So inline void show C out value of yes. So that's nothing but the yes. Okay, so this one it will be taking a long time to execute. In general, the function which is actually performing this input output operation should not be defined as inline, because it's going to spend a considerable amount of time. Okay, but the inlining of show function is of limited value, because the amount of time that is needed by the input output statement will be far exceeding the overhead of the function call. Okay. This is the significance of the compiler. So depending upon the compiler you are using, the compiler can give you some warning if the function is not expanded inline. So maybe in Java or maybe C hash, we do not have inline function. But in Java, the compiler can perform inlining when the small final method is actually called, because final methods cannot be overridden by the subclasses, and call to the final method is actually resolved at compile time. Okay, but in C hash we will have JIT compiler, so that also you can optimize the code by inlining that small function calls. Okay, so just like replacing the body of the small function when it is called in the particular loop. So this is the summary of the inline functions. Inline functions are valuable features of C++. An appropriate usage of inline function can actually provide performance enhancements, but if inline functions are used arbitrarily or imaginarily, then they cannot provide better result. Okay, in other words, don't expect like better performance of the program. Okay, and don't make every function inline, so that also make it up. Okay, so you make it in such a way that the inline functions are very small. Okay, that's how you will go for the best practice. So these are the default arguments in C++. Like it's nothing but a value which is actually provided in the function declaration that is automatically assigned by the compiler if the caller of the function does not provide a value for the argument with a default value. Okay, so in this case, any value which is passed, the default value will be overridden. Okay, so this is an example to demonstrate use of default arguments. So we need not have to write 3 sum functions. Only one function works by using the default values for third and fourth argument. Okay, so this is a C++ program to demonstrate default arguments. Okay, in C++, hash include IO stream using namespace std function. So you have the function with default arguments. So it can be called with 2 arguments or maybe 3 arguments or maybe 4 arguments. So int sum of int x, int y, int z is equal to 0, int w is equal to 0. Okay, so you return x plus y plus z plus w. So that is how you will go for. Okay, so that's a driver code in main function. So statement 1, so see out sum of 10 comma 15. Okay, then you have statement 2, see out sum of 10 15 25. Then you have statement 3, see out sum 10 15 25 30. Okay, then return 0. Okay, so in the output, if you see, first one it will be finding 10 plus 15 25. So this one 25 50. This one it will be 80. Okay, so that was how you'll go. Okay, in statement 1 only 2 values were passed. Okay, so the variables z and w, take the default values as 0. In statement 2 3 values were passed, so the value of z is actually overwritten with 25. And in statement 3 4 values were passed, so the value of z and w are overwritten with 25 and 30. So this is how overriding procedure takes place. So this is also another case when function overloading is done with default values. So which means that we have to make sure that it will not be ambiguous. Okay, so the compiler will actually throw an error if it is going to be ambiguous. Okay, so this is a modified version of the above program. Okay, so the C++ program to demonstrate function overloading in the default argument. So hash include IO string using namespace std function. So this is a function with default arguments. It can be called with 2 arguments or maybe 3 arguments or maybe 4 arguments. Okay, so int sum, okay, of int x, int y, int z is equal to 0, int w is equal to 0. So everything we are mentioning in the single line. Okay, so return x plus y plus z plus w. Okay, so you'll have int sum of int x, int y, float z is equal to 0, float w is equal to 0. Okay, then return x plus y plus z plus w. So this is how the function overloading takes place. So driver code in main function. So you will have see out sum of 10 15, see out sum of 10 15 25, see out sum 10 15 25 30 and return 0. But if you try to execute this one, okay, it will be showing an error message. Program C++ in the function int main, that is the driver code. Program 1720, you will have the error call of overloaded, which is nothing but sum of int comma int. So that is ambiguous. Okay, so see out sum of 10 15. So this line it will be showing the error. Okay, and also program CPP, okay, candidate in sum int. or int sum, int x, int y, int z is equal to 0, int w is equal to 0. So this is actually function overloading. Even for this one also, int comma float. So that's also function overloading. Okay, so int sum of int x, int y, float z is equal to 0, float w is equal to 0. So we will be getting the error message. So this is the summary of the default arguments. So default arguments are actually different from the constant arguments. As constant arguments, as the name implies, it cannot be changed. Okay, whereas default arguments, it can be overwritten if required. So default arguments are actually overwritten when the calling function provides value for them. For example, calling a function of sum 10, 15, 25, 30 is going to override the value of z and w to 25 and 30. Okay, so during calling of the function, the arguments from the calling function to the call function are actually copied from left to right. So which means that the sum of 10, 15, 25 will actually assign 10, 15, 25 to x, y and z. So the default value is used especially for w only. Okay, so once the default value is actually used for an argument in the function definition, so all the subsequent arguments must have the default value. So it can also be stated that as default arguments are assigned from right to left. Okay, so for example, the following function definition is invalid as the subsequent argument of the default variable z is not default. Okay, so which means that it's invalid because z has a default value, but w after it does not have a default value, like int sum, int x, int y, int z is equal to 0, int w, so that z has a default value. So these are the advantages and disadvantages of default arguments. So default arguments are useful whenever we have to increase the capabilities of the existing function by adding another default arguments. Also, you can reduce the size of the program. So that also. So default arguments improves the consistency of the program. Okay. And disadvantages, it increases the execution time as compiler need to replace the omitted arguments by the default values in the function call. Okay, so that it is going to increase the execution time, which is a problem, which is a disadvantage. Then finally, you have return by reference in C++. So both pointers and references have good relationship in C++. So the major difference is that pointers can be operated like adding values, but references just like alias, same as set of another variable. Okay, so functions in C++ can return a reference as it's going to return a pointer. Okay, so when the function returns a reference, it means that it is going to return a implicit pointer. Okay, so return by reference is much different. Okay, like it means it's very much different from this call by reference. Okay, so functions behave very important role, especially when values or maybe pointers are returned as reference. Okay, so we'll have this example: data type ampersand function name of parameters. Okay, so this data type is nothing but the return type of the function, and here parameters are nothing but the passed arguments to it. Okay, so this is an example of return by reference. So C++ program to illustrate return by reference. So hash include IO string using namespace std function. So this is a function to actually return as a return by reference. So int ampersand. Okay, return value. So this is how what you are going to have the reference, int ampersand x. So you print the address. So see out x is equal to, and you will have the address. The address of x is nothing but ampersand x. Okay. Then you will have the return reference, return x. Okay. Then you have the driver code, int main function, int a equal to 20, int ampersand b. Okay. So that's the thing, address is equal to return value of a, and you are going to print the value of a and its corresponding address. So see out a. Okay. So then also the address. Okay, so ampersand a. Then print b and its address. So see out b. The address of b is ampersand b. So we can also change the value of the a by using the address return by return value function. So since the function is going to return an alias, okay, of x, which is itself an alias of a, we can actually update the value of a. So return value of a is equal to 13. So this one, it will be assigning the value to the return alias as 3. Okay, so see out a is equal to, it's nothing but a, and of course the address of a is nothing but ampersand a. Finally, return 0. So maybe in the output, if you see x is equal to 20, address of x is nothing but that address. A is equal to 20. The value of A is nothing but that address, same address. Okay, right. And B equal to 20. So everything is being assigned. Okay, so that everything B. Then same X. Okay, the address X is 20. The address of X is nothing but that. Okay, then A is equal to 13. The address of A is nothing but this one. So reference is nothing. It's nothing like alias. Okay, so it's nothing but an alias of another variable. So the address of A, B, X, if you can see here, A, B, X, everything, it does not change. So this is the equivalent work for you. Requirements for searching, specification of the search problem, LS and BS, linear search and binary search. Please complete them as soon as possible in the MS, and I will be checking them.